Hello, hi everyone. Welcome to the Developer Week Management and the AI Dev Summit in San Francisco. My name is Maher Hanafi. I'm the Senior VP of Engineering at Betterworks. Honestly, if you look around today in the engineering teams you might be involved in or managing, one thing comes to mind is that the AI adoption battle is won and over. The AI tools are here and they are here to stay. They are plugged in everywhere in our IDEs and our CLIs and our tools. But the engineering leaders are still have something to deal with, like a big obstacle, and that's the trust gap. I think over the last few years, we focused so much on driving engineering the velocity, celebrating how fast our teams could go and could generate code. But at the end of the day, I think we failed to anticipate that there were some severe downstream friction when it comes to the acceleration, honestly. And there was a hype cycle that we ended up all finding out and then working through. So today's talk is about how we survive this and how we deal with the trust gap and how engineering leaders must also adapt to this new era we live in of AI generated code. So we'll be talking more about that and how we deal with technical debt, the engineering talent, especially the junior talent pipelines, how we build these things, and how we put together a strong structure to navigate these things in the future. What makes this moment even more fascinating today is, that the AI adoption among developers is extremely high. Like some data from Stack Overflow last year showing is 84%. Developers are now using AI tools and on a regular basis. I think this number could be in the mid 90s now in 2020, mid 2026. Honestly, for my teams, it's 100%. So with that being said, some other data are also showing that only 29% say that they truly trust AI or the output of AI. So that creates like the other values are showing 96% say that they do not fully trust AI generated code at all. So now here's the most important number on this slide. It's that 48%, only 48%, consistently verify AI generated code before committing it. So that leads to us to wondering, about a few things, or trying to understand this asymmetry that seems very dangerous because there is a high usage here. Adoption is at its peak, but the trust is still questionable and it's still low, and also the inconsistent verification creates an environment where it creates more risks. So that is the definition of the trust gap because you have high adoption, low trust. The bottleneck today in the software development is, or was before, like a writing software, generating software. So we had to go through phases of like learning and adapting and designing and decide the best design patterns and all of that. But that bottleneck is not anymore the same today. I think AI dramatically accelerated production and code generation, but verification still needs to scale with a human speed. So it's like having a big pipe of like code being generated while you have a smaller diameter pipe of like human review. So engineering leaders are in this position now where they need to manage the tension between those two different speeds. Naturally, AI creates definitely a lot of acceleration that we will be talking about, but also at the same time that friction. And that's what I want to talk about in this slide, which is, how this acceleration has a double edge is considered a double edged sword. On one hand, you have the wins that are real. You have teams are shipping faster. We've seen, internally at Betterworks as an example, we've seen upgrades, very very frequent upgrades that we need to do that we know these usually take like 10 days human work, and using AI we turned that down to 3 days and even less, based on some of the metrics. So AI is really incredible at unblocking us as well when it comes at using AI as like an on-demand senior junior developer. You can delegate work to, and you can guide and ask to write boilerplate code, generate some tests, explain legacy code, or even building scaffolding APIs. So that's really good and definitely on the wins part. And then last but not least is it keeps developer in flow, like which is very important for velocity and productivity. But while engineers are spending more and more time in these areas, they're spending less time finding definitely syntax and dealing with architecture, and focus more on the architecture of the product outcomes. So that takes me to talk about the friction that as equally real. So first is the trust gap that we defined earlier. That is like the gap between that the usage, the extreme high usage we see today, which is nearly universal, and yet the confidence that remains to be proven and remains very low. Second is the review fatigue. So PRs are getting larger and more complex. Some studies show that AI generated PRs weight close to 5 times more now in the pipeline queues, like the review queues. So to be picked up and then reviewed. And then on top of that, there is risk of like skill atrophy, which could impact different levels of seniority for our engineers, but especially impacting the junior engineers. So all of this changes how we think about how we grow our teams and how we deliver and how velocity is measured. But that leads directly to one major shift, which I would love to talk about. The shift here is all about where the bottleneck is in the software development lifecycle, and it seems that there is a core operational transformation that is happening today in our engineering organization, because historically software delivery looked like something like this, where humans spend more of their energy writing code and then kind of equal amount of energy or maybe less in reviewing, because that was the final checkpoint. Now the flow is like almost upside down. The AI generating enormous amounts of code instantly, and humans spend their time auditing, and that time being used in correctness, architecture, security, maintainability, business logic is a considerable amount of time. And some of the data is showing that 81% of leaders reported that the time that AI is saving is being reinvested in auditing and verification. So even if AI seems like it's helping us generate more code, it doesn't mean necessarily that it's helping us, deliver and deploy faster. It's still that time saving we do is invested somewhere else. Engineers themselves, ICs, reported that 1/3 of the daytime is spent on invisible work. It's definitely reviewing the AI outputs, putting and orchestrating AI agents and sub agents and all of that. And then we talked about how much these are, this AI generated code is waiting in the PR reviews and maybe later is waiting on QA and all of that. So the human verification side has been the biggest impact when it comes to the way SDLC has been shifting. And that is exactly what I want to talk about next, because it seems like at this point in the software engineering, life cycle in general, there is a place where we need to redesign this around verification that will eventually help us with managing the quality, because otherwise the quality will collapse. So let's see what will cause this kind of quality to collapse. One of the very important and concerning aspects of AI generated code is that it often looks correct. 61% of developers say that AI generated code appears right, like it looks good, syntax looks good, structure looks good, but in fact, it doesn't necessarily do the job as expected. So it creates what is known as the hallucination loop, because the way it works, software engineers go and ask AI, and then AI will generate this code pretty fast. And then the next step for the software engineer is to go and review this code to look at it, and then find these bugs that, because of lack of context or like for requirement clarity and all of that, it leads to bugs or undesired, I would say, code. And then you need to debug that and understand, and you need to reverse engineer the intent that AI had. And then with all of that, you need to send it back to the AI by asking again another question. And we go that again and again into that loop until we have the final result. So if it was just one run, it's definitely time saving, but it seems like we go into these loops again and again. Obviously, teams today are adapting to the agentic era and the sub agents era, and like a lot of things are done in a way that leads to less of these loops, but they still exist. And that's the problem, is that AI generated code looks really well and good and in good shape, but maybe it doesn't serve. So that's where the teams keep coming back to the idea that AI is fast, but every answer still requires human proof. And then organization, when they are optimizing only for the generation speed, they accidentally create these rewrite loops, and there will be churn in the code, and a lot of the code has to be rewritten again. So it seems like developers are spending cycles fixing the edge cases that AI didn't know about, the hidden assumptions in the unwritten rules, architectural inconsistency, security gaps, and the list is long. So the risk here is not just a catastrophic failure every time. The risk is a silent quality collapse over time and quality erosion over months. So, and that's why I think we need to redefine technical debt itself, because within the AI era, um, we see a lot of AI era. We see a lot of new aspects of technical debt, which I want to summarize in these four different aspects or of technical debt. I think historically technical debt mean the like messy code, shortcuts, outdated architecture. But with AI introducing entirely new categories of debt, I think the first important one that we're all very familiar with is the context debt. It looks like AI does not necessarily understand your organization undocumented, assumptions, tribal knowledge, historical decisions, business nuance, operational realities. All of these things could be somewhere else in Jira, in Confluence, in Google Docs, and Google Sheets, but they are not there for AI to be used. So that is a technical debt, which is called the context debt. So engineering teams need to go and build context engineering and harness engineering pipelines for this data to show up, so AI can stick with the guidance and understand these missing pieces to drive the best software. Second, consistency depth. AI tends to generate locally optimal solutions, not necessarily global coherent systems. So this is where you need to also, as part of your engineering AI context pipelines, you need to expose it to more design patterns and things that exist across different repos in your organization, so it can create consistency in the code base. Without that, you will be building up consistency depth, and you will be dealing with a different design patterns created by AI. Third is the verification depth. Code volume nowadays like outpaces the team's ability to validate it. We talked about this and how the bottleneck is moving to verification. So all that is becoming also a technical depth because we are building up more and more things that we need to revisit and review over time. And then one of the most important also missing pieces is the ownership debt or maybe accountability debt. Um, why I'm talking about this way, because it seems like we don't know necessarily like who is the most responsible or accountable person for something when it doesn't work. And one very dangerous phrase you can hear these days is like, I don't know, AI generated that. So if you're hearing that as an engineering leader, I think this is a big red flag that you need to be involved in and knowing how things work and how help your team navigate this. And also, if you're a software engineer saying this, I think you should also work as a team to figure out why any piece of code is considered like owned by AI. That should not exist. The moment anyone pushes the button to commit the code that is generated by AI, that person is the owner. Um, but I think the most overlooked problem is not necessarily just purely technical. Sometimes it's psychological. So for that, I think the human factor is very important. Reviewing AI generated code has a cognitive load that we all very familiar with now. Reviewing a human code is quite different from reviewing AI code. With a human code, we kind of understand the intent and we have like practices and years of understanding and collaboration. With AI, all you do is always reverse engineering what the AI intent was. And all of this is not necessarily documented. You're just trying to reconstruct the logic in your brain when it comes to how AI was reasoning. And then um, this kind of cognitive load over time leads to vigilance decrement, meaning that over time our attention degrades and we start, missing pieces when it comes to the review process, and we start slipping, bugs and mistakes and parts. Why? Because as we said earlier, AI generated code looks really great about most of the time, and sometimes depending on all of the different types of technical depth you have, it might be not good. And again, some cognitive science have been showing that 20 minutes or more can lead to a significant drop in vigilance and attention. So that doesn't work. So what happens from here? I think what happens is engineers get exhausted and became kind of numb to reviews, and they will give this superficial GTM. Yeah, it's generated by AI, it worked and it should work, or someone else will catch it. So it's not necessarily something for me to catch. And then the other thing is, reviewers will start skipping long, repetitive, reviews because they are again exhausted. They will start over trusting the AI and saying, "Yeah, it worked the last time we did it, so it's going to work this time as well." So all of these are risks and dangerous areas to go into as an engineering leader and as a software engineering team. So um, for that, I think if we continue to measure, teams' performance the way we used to do it before, based on velocity and throughput and how much they generate, I think we are unintentionally rewarding review shortcuts, and that doesn't work. So I think we need to focus more on the long-term impact and especially, how how this is, being addressed in a diverse team in terms of seniority levels. One of the areas that I'm very concerned about, honestly, is like how the junior engineers are, going to use AI, and or how they are using AI already. And I think the data shows that they trust AI significantly more than senior engineers. Why? Because it's experienced engineers. They have these scars and background experiences where they had more internal models for detecting subtle errors, issues or things that they know it's not going to work. So I think they have a better understanding where AI might fail, and they are skeptical towards that. So they are kind of tuned to just catch these things, and when AI shortcuts some of these areas. And AI is also very good at that because it's going to give you the final results. So it's kind of skipping the learning process that we went through as software engineers before by debugging and experimenting and reading documentation, tracing and struggling through all of this ambiguity. Now AI gives you straight the answer, and there is a risk of like expertise loss and skill atrophy and things like that. So when AI is completely bypassing this whole thing, I think the data has been showing that it's not working really well for teams. But there is an area where AI could be good, and that's where it's used as a sort of like for conceptual design and conceptual understanding. So when it's used in that way to just help people learn versus just be a typing machine for you, it's good, and it helps you really understand the code and understand what you're building. So that's really a good side, and that's where we need to put more of our attention as engineering leaders, is how we leverage AI to train our teams and get better. Because if you focus more on that long term, you'll get the better, more AI enabled teams versus teams that are just delivering more code. The issue will move towards other places in the SDLC, and that creates a problem. So asking AI to explain concepts and to walk through some of these big ideas when it comes to software engineering, I think helps a lot. So the question now becomes, what should engineering leaders actually do when it comes to all of this? And I think this is the second part of my presentation, where I will be talking about strategies based on personal experiences working for Betterworks, things that worked for us. And this is more the practical side of the section of the presentation. So I'm going to be listing just 6 strategies for now. I think there will be more. And I think even out of these strategies, there will be a changing over time. But just to list them and go in details later, we will be talking about standardizing verification, upgrading the software development lifecycle. We'll be talking about context engineering and how we intentionally work towards that, how we will protect our junior engineers' growth, how we reinvest AI gains into refactoring, because I think that's an area that will save us more time long term, and then how we start measuring the right things. So let's start with the culture and how we shift our culture from generation to verification. And I think that's the biggest mindset shift for leaders that must drive, because the job is no longer about generating code. It's more about generating confidence. AI gives us speed. Human will contribute by providing judgment. And then the verification gates you have create trust. All of this create like a sustainable quality, combination. This also means that the metrics we used before must evolve and must change into something a little bit more different. I think historically we track different metrics, lines of codes, PRs generated, and all of that. But I think today we need to focus more on different areas that will help us kind of also adapt to the new role of software engineer, which is more about architecting, curating, and also verifying. Um, Not just coders or developers, generating code as an output. I think that is changing significantly when it comes to the definition of software engineering. So organizations that embrace this shift early on will definitely outperforms the one that are still optimizing only for speed and output volume. But the culture alone is not enough. The delivery pipeline itself has to evolve. As we said earlier, we talked a lot about the SDLC in the age of AI and how it needs to be upgraded. We need AI native control pipelines. That's the whole idea. We need the model that is being used to generate code, to be also used to automate the quality gates and validate syntax and standards. I think today, with the capabilities we have with agentic review systems, I think we need to do more and more test edge cases, because I think they're very capable of imagining test scenarios and edge cases, and we work through that. AI can also help a lot when it comes to architecture, audits, verification of system alignments, and making sure that we're designing towards a scalable, modern, evolving system versus a one-off or a silo approach. And then that leaves for the human more focus on the areas where their judgment is more important, and that's risk, architecture, and release decisions. This is very critical, and the human reviewers here should not just spend their time and energy checking for formatting or boilerplate code base. We talked about that. I think machines are definitely very good for that. I think humans should focus more on strategic correctness. And the goal here is not to remove the human from the loop of software engineering, but more to elevate them to be used for the highest leverage points. But even, assuming all of this has changed, even the strongest pipeline fall without one thing, and that's context. We talked about context a lot in this presentation so far. And I think one of the biggest misconceptions when it comes to AI is that the model quality alone determines the output quality. Like we talk about these coding models and we say, okay, well, this is the best model, but that's not enough. In reality, context is more important sometimes than the quality of the model. Dora metrics and Dora research have been driving a lot for the last few years when it comes to AI, and they have been demonstrating that teams with healthy context ecosystem report dramatically higher confidence in AI outputs. You might be asking why, and I think the answer is easy, because AI performs better when you understand the context of the architecture decisions, even the history of these decisions, from other documented areas, the conventions that you agreed on doing, the API design, the historical patterns, and even some of the upgrades you have done over the years, and then some of the business constraints, being a SaaS, being an HR tech, all of these impact the decisions, and AI models should know about these to deliver the best software. Otherwise, it will be just giving you software fast, but not the right quality software. That means context engineering becomes the new infrastructure. I think working on your Claude.md, your cursor rules, your MCP server, and your kind of architecture decision records, all of these will become as important as the software itself. All these parts of the big picture today in the new era or the new age of AI are as important as the software itself, and they are all about, operational success and excellence over time. So another thing also we didn't talk about so much is the importance of strict governance around the inputs and outputs of the software. So AI outputs should always be treated as a proposal, not the truth. And that's where, that mindset about, taking a look at the software and, even if it looks really good, going deeper into evaluating and verifying that is so important. So especially in regulations, or as regulations are going more and more, like the EU AI Act is increasing oversight over the requirements, and I think in later this year they will start requiring human oversight for high risk deployments for the software platforms. So now let's talk specifically about the seniority level and the junior level. So one of the areas where we found gaps and we really strategically wanted to invest in is intentionally address AI literacy and introduce new programs for all levels. But the focus is more on junior to mid-level engineers, because there is that risk of like skill atrophy, or even like kind of bypassing the whole learning experience, or like building up experience over time by experimenting and doing mistakes. So I think this program is broken into three phases or three levels. The first one is all about awareness. So it's understanding and being aware where AI fail the most, and understand all of these issues and the requirements to address these and to go around them, and understanding the AI, or take a look at AI cause incidents from the past or the history, or even from research. I think it's very important, because that's kind of help us have tangible understanding and grounding truth about AI capabilities, and move on from the hype cycle. Level two is definitely very strategic task selection. So we help our engineers at their different levels to just you know be involved in the architecture of the software. So that's why sometimes we prohibit the usage of AI in some areas, including architecture and security. We also, we help the engineers on how to use AI, not just, if they have to use it or not, so they can learn. Definitely AI is here to stay, but how do they use it? How do they set it up? And how they look at the output and the input going in and out of the AI is very important. So um, going into the last level, which again require all these previous levels to be passed, and then you go into more a shift to the shift code review design, where um, you start questioning, why AI is doing these things, why AI is responding this way, why AI did design this, and you even ask yourself, or you are been asked by your team, like, how would you do this without the use of AI? I think this approach will help us, build up more and more the quality verification that is needed and the review mindset that will lead to better software at the end of the day. So the objective here is not to reduce, by introducing these frameworks, is not to reduce the use of AI. In fact, it's the opposite. It's more about preventing the cognitive dependency on AI and becoming just numb to the idea of like generating code, reviewing it. We need to be involved. So maintaining this kind of balance between the AI and the learning and the trust in AI, I think is very important. So finally, we need to stop kind of spending all of our AI saving into feature throughput. And this is where I talked about earlier, like the new definition of technical debt. So it's very good that, or it's a good idea that organization invest the dividend they have from the AI speed into creating long-term, stability. And by that, I mean a lot of organizations today are doing a big mistake, which is, yeah, AI helped us save, XYZ percentage of time and resources. Now we're investing that into our roadmap. So given putting all more roadmap pressure will definitely not help you long term. It looks like very narrow focused and looking at the short term acceleration, but I think it's more about how you survive this long term. So at least something we have been thinking about is how we invest all of this saving into different areas. I think mainly refactoring the hotspots where we think we have maybe some bad design patterns or old legacy code base that needs to be improved. Because otherwise, AI will be using that to generate even other bad design patterns or reuse them, which that was not the intent. The intent for AI to come and help us solve these and build better software over time. So that's one area. We talked about the legacy software and how we need to modernize it anyway. And then the other thing is testing. I think improving testing coverage and helping using AI to figure out all of these edge cases and use cases, I think is a good area where AI brings a better kind of quality. And that leads to, at the same time, having a cleaner code over time, but also better code that you can use for the next kind of loop and next iteration of using AI. So the more you save now, the more it will help you on the long term. So the focus here is to continuously improve architecture. All of this will give AI more and more advantage over time. And to make any of this sustainable, we need to start measuring the right things. Like we talked about that enough to get to this slide. And I think the idea that we still like use lines of codes and commit frequency, PR count as metrics for performance is an outdated idea. I think in the era of AI, we need to measure what matters, and this could be the code turnover ratio. It could be the defect escape rate, or how much your PRs have taken in terms of time or queue wait before they get reviewed and published. The review coverage and maybe the AI co-chair versus quality. Like all of these new metrics are mainly focused not on just the activity of the software engineering team, but more on their flow of work, on their quality and their impact. And I think this is where organizations should be investing a lot. So what can you do immediately after learning all of these, at least 6 strategies? I think there are quick wins to achieve now, and there are long-term bets and wins you can start working on later. I really want to end this kind of presentation with a practical implementation guidance. And with that, I think let's go and look at the now thing. I think now is very important to start setting static and dynamic, security testing using AI in your CI/CD pipeline. I think it's very important because AI can introduce risks in your architecture and your security without you knowing. So it's very important to make sure you have that in place. Label any AI generate PRs. You need to know when AI is used. And I think honestly, over time, this will be decommissioned because almost every AI PR will be AI generated or AI assisted. So it's very important to start knowing that now and working through it. The size of the PR has always been a problem, so it needs to be kept under control for the review to work and not to become a cognitive load for the engineers. Ban AI from being used in some places, and make sure your engineers are continue to contribute to the architecture and to the security without the AI involved. Track your code turnover, use the right metrics, as we said, and then run recurring AI incident reviews. Like when AI fails at any level, like just do a review or retrospective and see why and how, and use that in your strategic kind of learning framework for growth. Now, what you can do next immediately as you set up this, and I think where I see the biggest future bets to be in is the agentic review pipeline. We talked about the new SDLC, where there's a big pipe for code generation, but the later steps are all like thinner pipes. I think we need to widen these pipes over time, and that kind of starts with the agentic review pipelines. Spec driven development, I think, is very becoming very popular and bringing a lot of value and stability to AI. So I think that's an area that needs to be considered. And work more on the shared context, on the harness engineering and all of that. Make sure you train your engineers at different levels, but focus more on junior, mid level, and up. And then start creating these new measures and new dashboards. Be able to reflect metrics in the AI SDLC. I think it's becoming very important. So, in other words, just prepare your team for the new AI generated code era, and don't forget about AI governance and the regulations and all of that. I think AI will be coming to our the regulations will be keeping an eye on all of this and ensuring that it's used fairly and impacts is positive on the software we deliver. So with that being said, let's go and close this with one final idea. I think AI is definitely not replacing engineers or engineering leadership. It's definitely also increasing the importance of engineering leadership, in fact, because the hardest problems are no longer syntax problems. We're taking this a little bit higher. We're going with, trust problems, judgment problems, system design challenges, organizational design problems. So all these are more important now for the engineering leaders to consider. And I think the companies that will win the AI era will not necessarily be the ones generating the most code. That's the I think the summary of all of this. It's not about speed. It looks more like it's about acceleration. So if you focus on the acceleration of your team, it's better than focus on the current speed of your team. So with that being said, yeah, I want to thank everyone and thank you for following my session. And I hope you find value in it. Happy to connect with anyone on LinkedIn and beyond. And thank you so much.